Hello students. In the previous videos in this video series, we talked about what scientific notation is. We've shown you how to convert normal numbers into scientific notation and how to convert numbers written in scientific notation back into ordinary numbers. So in this last video of the series, we're going to actually do some calculations in scientific notation. So let's have a look at the question. Radio waves travel at about 3 by 10 to the 8th meters per second. If the moon is 384,000 kilometers from Earth, how long in seconds does it take for a message to travel from the moon to the Earth? So what we're trying to find is time. The formula for time, which you would have learned in a science class, is distance divided by speed. For example, if I'm going 10 kilometers at 5 kilometers per hour, it takes me 2 hours to get there, so 10 divided by 5. Okay, the first thing we have to do is turn this number into scientific notation, and we've also got to be careful because we have different units. So I'm going to work in meters rather than kilometers, so I've got to turn this first into meters and then write it in scientific notation. So 384,000 kilometers. Well, there's 1,000 meters in a kilometer, so times 1,000. And that gives me 384,000,000 meters. Okay, let's write that now in scientific notation. So a number between 1 and 10. So I moved my decimal point till it's after the 3. Altogether, I moved it 3, 6, 7, 8 places. So that is times 10 to the power of 8. Okay, now we're ready to do our calculation for time. So time is distance divided by speed. Well, the distance is this number here. So 3.84 by 10 to the power of 8. The speed is 3 by 10 to the power of 8. So it turns out in this question I could actually cancel those out. But for practice, I'll go ahead and type the questions into the numbers in scientific notation. So let's go ahead and do the calculations. So first we hit the fraction button. On top, I'm going to write 3.84 multiplied by 10. There's my raised to the power button, which is 8. Then I right-click to get the cursor down to the bottom of the fraction bar and down, and then 3 multiplied by 10 to the power of 8. Arrow across, arrow across. Okay, quick check. Whenever I type things into the calculator, I always check that I've done it correctly before I press the equal sign. So 3.84 times 10 to the 8th. Divided by 3 by 10 to the 8th. Yep, all that looks good. And there's the answer, 32 over 25 as a decimal, 1.28 seconds. So it takes 1.28 seconds for a radio signal to get from the moon to the Earth. Okay, I'd like you to have a go at the next question on your own, please. Okay, let's see how you went. So 2 bacteria cultures, one containing 6.2 by 10 to the 11th cells, and the other 3.5 by 10 to the 10th cells are combined into just one flask. How many cells are there in the flask? So to answer part A, we have to add those two numbers together. So let's go 6.2 by 10 to the 11th plus 3.5 by 10 to the 10th, and I can write it over here. Let's get out our calculator. We'll drag it to the and we'll keep it on this side so I don't hide the numbers. And we have 6.2 times 10 raised to the power of 11. Arrow across. That's important, that little arrow across, to get the cursor back onto the ground, so to speak, times, delete that, plus 3.5 times 10 raised to the power of 10. And because it's a bit of a hassle to have to scroll back, I'm just going to be, I'm going to assume that I've typed it in correctly. I'm not going to check it this time, and just equals. And that gives me 6.55 times 10 to the 11th. So know that it's actually put the answer in scientific notation for me. So 6.55 times 10 to the 11th. Notice, by the way, that this number is not that much bigger than that one. The reason, of course, is this power of 10 is smaller than that. So that number there is less than a tenth of that one. So the total is going to be just a little bit bigger than this number here. Okay, so that's the answer to part A. Now part B, if the bacteria population doubles in size every 12 hours, how many cells will there be after 3 days? So what do we have to do to this number here to answer the question? Well, if it doubles after 12 hours, it's going to double. Another 12 hours, which is 1 day, it's going to double again. So it's doubling and then doubling. Well, that's 4 times. Doubles and doubles again. Well, times 2 is 8, times 2 is 16. And then after 1 more day, doubles again. So 16 by 2 is 32, and 32 by 2 is 64. So I could say multiply by 64, or you could just sort of say I've doubled it 6 times. So that 2 to the power of 6 just means I've multiplied by 2 6 times. Every 12 hours for 3 days, I've done it 6 times. Okay, let's go ahead and use our calculator to turn that into a number in scientific notation. So clear what I have. 6.55 times 10 raised to the 11th power, put the cursor on the ground, multiplied by 2 raised to the 6th power. Okay, quick check. 6.55 by 10 to the 11th by 2 to the 6th is correct. And there's the answer in scientific notation. I'll write it down here. Oops. 4.192 times 10 to the 13th. 4.192 by 10 to the power of 13. So there's the answer in scientific notation. And finally, let's just write it as a normal number. So 4192, I've got to move the decimal point 13 places to the right. So there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Put in some commas. 1, 2, 3, and there's the answer. And I'm not even going to try to say that. Okay, one last question just for fun. Go ahead and read the question and have a go, please. Okay, let's see how you went on this last question. Our planet has a total land area of 148 million square kilometers. So let's write that in scientific notation. 148 by 10 to the 3, 6, 7, 8. So by, 1.48 by 10 to the 8th. That's the land area. And the population is 6.6 by 10 to the 9th. If all the land was shared equally, how much would each person get? So you got to divide. Now, which way do we divide? Well, just ask the question, are we working out area per person or person per area? And the question says if all land was shared equally, so in this case, we want land per person. So I'm going to put land on top, per person. So you got to, if you just think about it, say it out loud, normally you can figure out which way you have to divide. So land per person. So the land area, or I should say area per person is probably a better way to say it. So area per person. So I'm going to put the area on top, 1.48 by 10 to the 8th. And the number of people is 6.6 by 10 to the 9th. Okay, let's go ahead and use our calculator to work that out. Clear. Once again, we need the fraction bar, 1.48 multiplied by 10 raised to the 8th power, arrow across and down, 6.6 by 10 raised to the 9th power. Quick check. Yes, all that looks good. And equals, and turn it into a decimal. And each person gets, I'll do it to say 4 decimal places, 0.0224. 0.0224 kilometers per person. Okay, there's the answer to part A. Now we want to convert that into square meters. So the question, of course, is how many square meters in a square kilometer? Well, let's draw a quick little diagram to figure that out. There's 1 kilometer by 1 kilometer. And that's the same as 1,000 meters by 1,000 meters. So to convert square kilometers to square meters, I've got to multiply by 1,000 by 1,000, since the area is length times width. So I'm just going to have 0.0224 times 1,000 times 1,000, or times 1,000 squared. Let's do that calculation on our calculator. Whoops, I just hit the wrong button. Go away. And clear that. So 0.0224 multiplied by 1,000 raised to the power of 2. And that comes out to be 22,400 square meters. So that's probably a bit surprising that if we divide the land up equally, each of us actually gets quite a bit of land. Hopefully, my land will be in Sydney and your land might be somewhere else. Okay, that's the end of the video series on scientific notation. So if you understand indices, it's not too challenging to understand scientific notation. So thanks for watching, or thanks for listening. Bye-bye.